Hey everyone, and welcome. We humans, we learn stuff every single day. It's just what we do. But have you ever stopped to wonder how a machine does it? How does a piece of code actually learn? Well, today, we're going to peek under the hood and break down the three main ways that machines get smart. And trust me, it's way less magic and a lot more logic than you might think. Let's get into it.
So here's the plan. First, we'll get on the same page about what it even means for a machine to learn. Then we'll check out the three big learning styles: learning with a teacher, learning all on its own, and learning from trial and error. And then we'll wrap it all up with a look at the complete toolkit.
Okay, so first things first, how in the world do machines learn? To really get our heads around this, let's actually start with what we already know, how we learn.
It's a pretty fundamental question, isn't it? We learn to play an instrument or figure out a new recipe. It's intuitive for us. But can a bunch of code do something similar? The answer is a huge yes. But the way it does it is totally different. It's less about gut feelings and more about data and math. It's just a different kind of smart.
So let's start with the definition we can all relate to. Webster says, to learn is to gain knowledge through things like study or experience. Simple enough. That feels right. It feels human. But for a machine, well, we need to get a little more specific.
Now compare that to the machine's definition. This is from computer scientist Tom Mitchell. I know it sounds a little dense and academic, right? But the idea behind it is actually incredibly simple. A machine has learned something if it gets better at a task after having some experience. That's really it. Let's just break that down into three easy pieces. First, you've got the task, or T. That's the goal. What are we trying to do? Say, spot cats in photos. Second, you need experience, E. This is just the data it learns from. So thousands of pictures, some with cats, some without. And finally, you need performance, P. This is our report card. How do we measure success? For us, it's the percentage of cats it gets right.
And this is a perfect example you use every single day, your spam filter. The task is to figure out if an email is spam or ham, and yeah, ham is actually the technical term for not spam. The experience is a giant database of emails that you and I have already marked as spam or not spam. And the performance? Well, that's easy. It's the percentage of new emails it gets right. The better that percentage gets, the more it has truly learned.
Okay, now let's get into our first big learning style. This is called supervised learning. And honestly, the easiest way to think about it is like a student who has a teacher giving them an answer key for everything.
So let's imagine an AI that's trying to learn how to be a loan officer. Step one, we just hand it a massive pile of old loan applications. This is its training data. And here's the key. Every single application is already labeled with the result. Was the loan safe or was it risky? It's like giving a student a stack of practice problems that already have the answers in the back.
Now, after looking at thousands of these examples, the AI starts to see the patterns. It's not just memorizing, it's building its own internal rules. It might notice things like, okay, if a person has a high income and a long credit history, then the loan is almost always safe. It's creating its own logic based on the data it was fed.
All right, so our AI has studied up. It's created its rule book. It thinks it knows what it's doing. Suddenly, a brand new application shows up. No labels, no answer key. What's it going to do? This is the final exam. The AI takes that new applicant's information and runs it through the rules it just created. And based on all those patterns it learned, it makes a call. This one looks safe, or this one looks risky. It's applying what it learned to a problem it's never seen before. And that, in a nutshell, is supervised learning.
Now, there are basically two main flavors of this. What we just saw with the loan example, that's called classification. You're sorting things into neat little boxes or categories. The other flavor is prediction. And that's not about categories, it's about estimating a specific number. Think, what's the price of this house going to be in 6 months?
So, what happens if there's no teacher, no answer key at all? Well, that brings us to our second style, unsupervised learning. This is where the AI has to figure things out and find patterns completely on its own.
I think the best way to imagine this is pretend someone tells you to go clean up a super messy room, but they give you zero instructions. What do? You just start making logical piles, right? This is a pile of books, that's a pile of clothes, over here is a pile of electronics. You just naturally find the hidden structure in the chaos.
And that is exactly what this AI does, but with data. You give it this massive jumble of unorganized, unlabeled information, and just by looking at the properties of each data point, it starts to find the natural groups, the clusters. It creates order out of what looked like total randomness.
All right, our third and final learning style is all about learning from consequences. It's called reinforcement learning, but you can just think of it as learning by good old-fashioned trial and error.
You already know how this works. Think about how you train a pet. When your dog finally sits on command, what do? You give it a treat, right? That treat is positive reinforcement. The dog learns that the action of sitting leads to a really good outcome, a reward. And that's precisely how this algorithm functions. It's dropped into a situation with no teacher, no instructions, but it does get feedback. When it takes an action that gets it closer to its goal, it gets a reward. If it makes a bad move, it gets a penalty. And over millions and millions of tries, its one and only goal is to figure out the sequence of actions that gets it the most rewards. And this is incredibly powerful for things like teaching a robot how to walk or an AI how to become a grandmaster at chess.
So there you have it. We've just walked through the AI's complete learning toolkit. Let's do a quick final recap of the 3 core strategies we've just covered.
So let's tie it all together. First, you've got supervised learning. That's like studying for a test when your teacher gives you the answer key. It learns from labeled data. Then there's unsupervised learning. That's like being told to organize that messy room on your own. It finds the hidden structure in unlabeled data. And finally, reinforcement learning. That's learning by doing, like training a puppy with treats and praise. It learns from rewards and penalties. Each one is a different tool for a different job.
And that really brings us to the big, final question. Now that we have a handle on how machines learn, with a teacher, on their own, or through trial and error, the really important question isn't about the technology anymore. It's about us. The question is no longer can they learn, but what on earth should we be teaching them? Thanks so much for joining me for this explainer.